The way I'll always explain this is the following. Okay? You'll always factor your expressions, so start by factoring them. So in this particular case, I don't have to. There's no other factors than what's there. And then my next step is I'm going to create one single fraction, and the denominator of this fraction is going to be the LCD of every fraction involved in the problem. So I need a factor of x in my denominator. I need a factor of y in my denominator. So there's my LCD. Right? Now what I'm going to do is I'm now going to go back to each numerator or each fraction. I'm going to take whatever was originally in the numerator, and I'm going to multiply that by the factor, the LCD factor that's missing from its denominator. Okay, so which of these LCD factors is missing from this fraction's denominator? Y. So I'm going to multiply that by y. Okay, now move to the next fraction. Plus 2 times what LCD factor is missing from this fraction's denominator? X. Okay, and that is my simplified form. Now you look to see, are there any other ways to factor this and cancel common factors? In this case, there's not. So this is my simplified form. And now, the way this differs from what many of you have done. Okay, many of you, you're doing the same process, but hopefully you've kind of noticed when I explain things, I do a lot more sort of internal than necessarily writing it out. Some of you might have said when you find your LCD, you might go back to each individual fraction and say, what do you have to multiply the top and bottom of this by to get the LCD in the denominator? Y, right? Y over y, it's a value of 1. You can multiply anything by a value of 1 and maintain its same identity. Now, if we look at this second fraction, what would you have to multiply the top and bottom by to get the LCD? X over x, right? So that's the process that some of you may have learned this by actually writing all of that out. If you need to write it out, that's fine. I'm fine with that. But I'm not going to write it out. We're going to do this part kind of internally by writing our LCD. And then this top part is kind of the way that I'll say multiply this by whatever LCD factor is missing from its denominator. All right, so if this is your sum that you're looking to combine, right, you do have to factor everything. So when I rewrite this as factors, I have the difference of 2 squared, so it factors into the sum and difference of the terms that are being squared. Plus the next one, the denominator, again, can be factored. My first terms are x's. What 2 factors of 16 have a sum of 8? So you should see it's a binomial square form, but I can just write it out as the individual factors here. Okay, so when I move to combine these into one single fraction, my LCD, I need to take every factor that appears. So I need an x plus 4. That's not there already. An x minus 4, it's not there, so I put it. An x plus 4, which I already have, so I can disregard that. But I have a second x plus 4, so I do need another one. So notice my LCD contains 2 x plus 4s and an x minus 4. Well, because one of them is repeated, right? It's like a repeated factor. If you had 1 over 12 plus 1 over 6, what's your LCD going to be? Is it 12 times 6? No, because you think of 12 as being 2 times 6. So you need a 2, you need a 6, you need a 6, but you already have a 6, so you don't need to repeat it. It's because you're looking for the least common one. All right, so when we look at this, we have an x plus 4, I put that here, and an x minus 4, I put that here. Well, when we put an x plus 4 and an x plus 4, how many do I already have underlined? I already have one of them underlined, right? So I only need one more. You only need a total of 2. You don't need a total of 3 to get the smallest set of common denominators or factors. Okay, I'll have to try to explain it in some other examples because I want to move on here. Okay. So what you're going to do when you create this one fraction is now after you find your LCD, you're going to go back and take the numerator of your first fraction and you're going to multiply that by whatever LCD factors are missing from its denominator. So what's missing here? You have an x plus 4, you have an x minus 4, but you're missing the x plus 4. So we get x plus 4 here. Okay? And then we move to the next fraction's numerator, plus 3 times what LCD factor is missing from this fraction's denominator. It has both x plus 4's, but it's missing the x minus 4. So now what you would do to simplify this is you would distribute. So you get a 4x plus 16, distribute, plus 3x minus 12. So when you combine those, you have a net of 7x plus 4. So there's your numerator. And then your denominator is just going to be that whole set of factors. And now you do need to go back if from this form, are there any factors that can cancel? You still need to check. If you can simplify your resulting fraction, you need to perform all the steps that we're doing in 4.1 and 4.2 and to simplify that. But if not, then you leave it in this form. Now, did any factors cancel from the denominator here? No, same with up here. So you still need to be aware of domain restrictions, but in this particular case, there aren't any. So let's say we take this problem here. Okay, the first step is to rewrite everything in terms of its factor form. So we have difference of squares, x plus 2, x minus 2. Okay, we have a trinomial with binomial factors. First term's x. We take the two products of positive 2, whose sum is negative 3. So minus 2 and minus 1. And then the last one, again, a trinomial with binomial factors. First term's x. The two factors of negative 2 whose sum is positive 1, plus 1, or plus 2 and minus 1. So here are our factors. So what we're going to do is we're going to write one single fraction. We're going to find the LCD. So we need to go through and find all the unique factors in the denominators. So looking at just left to right, we have an x plus 2. We have an x minus 2. Okay, we have an x minus 2 in our next one. Do we already have one of those? Yeah, so we don't need to repeat it. We have an x minus 1. Do we already have that? No, so we do need to include that one as well. Keep moving. We have an x plus 2. Do we already have an x plus 2? Yes. And then we need an x minus 1. Do we have an x minus 1? Yeah, so here's our LCD factors. We have 3 of them. Okay, so what we're going to do is we're going to go back to the numerators and just start fraction by fraction. Take our numerator, 2x, times which LCD, which of these 3 LCD factors is missing from this denominator? X minus 1. Okay, move on to the next one. The sign carries, minus 1 times what LCD factor is missing from this denominator? X plus 2, plus the next one is a binomial, which is fine. What LCD factor is missing from this denominator? X minus 2. Okay, so here is how our numerator needs to be expanded. So now as we go through this, we do need to expand. So we get 2x squared minus 2x, distribute the negative, minus x minus 2. And now we FOIL this. So we get an x squared. We get an outer of negative 2x plus 1x nets us negative x. And then our last is minus 2. So if we combine all these terms, we get a total of 3x squared minus 4x minus 4. Okay, and that's all over the set of factors here. And now, we have to test and see, can we factor this numerator even further to simplify our fraction? Well, let's take a look at what happens. All right, the easiest way to test for this is just to see, if you take the product of these two, so 3 times a negative 4 is a negative 12. Are there two factors of negative 12 whose sum is minus 4? Negative 6 and a plus 2, right? So that means we could rewrite the middle term and solve this. All that's telling you is you have binomial factors here. So if you want, you can use trial and error, or you can rewrite the middle term. Let's say I rewrite the middle term here. So I drop down my 3x squared, drop down my minus 4, factor by grouping. So in this first pair, I can take out a 3x, leaving x minus 2. From the second pair, I can take out a 2, leaving x minus 2. So my common factor, binomial factor, is an x minus 2 from each of those. And then my remaining factors, 3x plus 2, are the terms of my other binomial. My denominator is going to stay just as it was. And then what happens? X minus 2's cancel. And so you wind up with your simplified answer of 3x plus 2 all over x plus 2, x minus 1. Did you cancel any factors from your denominators? Yes. So you need to account for that. X can't be 2. Is that demonstrated in this simplified form? No. Okay, so